children, how are you? Hope you are good. Get up for Diwali celebrations, children. Yes? And you should get up for studies as well, because we are starting with a new lecture, Force and Laws of Motion, lecture 7. Let's proceed. Today's thought, wow, very nice. The thought is, education is our passport to the future, for tomorrow belongs to those who prepare for it today. So, prepare for a nicer, better future today by studying thoroughly, working hard, and being dedicated towards your goals in life. Yes? So with this positive quote, before beginning the lecture, I want to share one thing. In the last video, in which we discussed the numericals, the lecture 6 on force and laws of motion, we discussed the numericals on Newton's second law. Remember? How many of you watched the lecture? Many of you watched it, right? The first question, the answer was, now you will tell me, what was your answer, children? The answer was 3000 Newton. What was the answer? 3000 Newton, which I have mistakenly written as 300 Newton, right? That was not a very big issue, not a major issue, because in that question, direct formula based question, आपको सिर्फ multiply करना था, right? But the question tested your honesty, children. Yes? Have I not told you to pause it and try? Before watching the solution, you have to pause the video and try the question yourself. How many of you did that? I'm very glad to share that one child, she commented the right answer below in the comment section. I want each one of you to work very hard, and you need to comment whatever the doubts and queries you have, right? You have to be honest and very truthful to yourself, like she did. She commented the answer, right answer below, and very politely asked whether it will be the correct answer, that is 3000 Newton. And indeed, the right answer is 3000 Newton, right? Should we now move on, children? So, our topic is Newton's third law of motion. And this is the last topic, last major topic of the chapter. After this, we'll be doing lots and lots of numericals. Again, one strategy, pause the video and try the question for at least 1 or 2 minutes before you see the solution, right? Yes, children. So before we see what exactly is Newton's third law, let's see some observations. When a player kicks a football, the football moves forward and the foot of the player moves backward. Ever tried playing football? You must have observed that, felt that really. When you kick the football forward, the football experiences a force, and you will also experience a force that pushes your leg backward, right? So you are doing an action on the football, that is action, and what the football is giving it back to you, that's reaction, right? What you are doing on the football is action, and what the football is returning back to you, that's reaction, like a return gift. Concept of a return gift works on Newton's third law, right? You can now see here, just a second. Can you see in the picture? The player is kicking the, right? Kick on the football and the football will return a force back on the player, right? I hope that's very clear. This is Newton's third law. We'll see the action-reaction pair. Okay, action-reaction pairs. Now the next slide. See. Now let's see another example. Action-reaction pair. When a ball falls towards the earth exerts a force F1. Exerts a force F1 on the ball to attract the ball towards its center, and the ball in turn exerts the force F2 to move the earth upward. Has it ever happened? Has ever the earth has moved upwards because of the ball? No. Can you tell me why? The mass of the earth is much larger than of the ball, right? So more mass means more force. Ball will move towards the earth and not the earth will move towards the ball, right? Which has more mass? Have we seen that force is directly proportional to mass? Mass किसका ज़्यादा? Earth. So which will apply greater force? The earth will apply greater force and the ball will move towards the earth, right? This is another example of the action-reaction pair, right? Two forces equal in magnitude, opposite in direction, constitute the action-reaction pair. Two forces that are equal in magnitude, F1 and F2, opposite in direction, action-reaction pair. Simple. See blue colored earth and orange colored ball. Right? Let's move forward now. What is the conclusion we draw from the observations above? Let's see. Whenever two bodies have influence on each other, they exert equal and opposite forces on each other. What are these forces called? Come on, answer that. First lecture. Yes, these forces are called the balance forces. Balance forces में position change होगी? No. Why? Equal forces acting in opposite direction will cancel out each other, right? Out of these two forces, देखो horses लिखा है. Forces. One is known as the action and the other is known as reaction. Right? Let's see the statement now. देखो. Red colored. Very important. Oh, just a second. Oh. See children, I've reduced the size of camera so as to adjust that. Yes, so we were on the statement. To every action, there's equal and opposite reaction. Action and reaction forces are equal in magnitude, opposite in direction. What type of force? Balance forces, right? Action and reaction act on two different bodies. This is a very important statement. Action and reaction forces act on two different bodies. Always and always, action and reaction forces act on two different bodies. Very important. Mark a 3-star. Quickly mark a 3-star. That's a very important concept for your exams. So here children, we have the next slide which states examples to illustrate Newton's third law of motion. So the first example is a ball rebounds after striking against a floor. Walking of a person, swimming of a person, rowing of a road are all examples of Newton's third law. They are all examples to illustrate Newton's third law. And this is just the names. I am going to explain them to you with the help of these beautiful pictures. Now children, let's see beautiful examples of Newton's third law. Right? Let's see the first example. The ball strikes on the floor. The ball exerts the force on the floor, and the floor exerts the force back on the ball, and the ball rebounds in this direction. Right? Understood? Whenever we walk, we exert the force on the ground backward. That is the action. And the crowd in turn exerts the force forward. And as a result, we move in the forward direction. Right? You can see the action and the reaction is mentioned here. Similarly is the case with the swimming. In swimming, the swimmer exerts the force backwards. He pushes the water currents backwards to move forward. And the water exerts the force forward. As a result, the swimmer moves forward. Simple. Recoiling of the gun is also the example of Newton's third law. You exert the force forward and the gun exerts the force backward. That is known as recoiling. And we are going to do the calculation for recoiling velocity of the gun in detail in the coming slides. Okay? Do you know why is it special holding a gun and using it? It's not very easy. You have to take it on your shoulder without any gap between the gun and the shoulder. The gun and the shoulder should be in very close contact. Otherwise, due to this recoiling, the gunman may get injured. Okay? So this is the phenomena of recoiling of the gun. And we are going to see conservation of momentum. Remember what is momentum? Mass into velocity is momentum, right? So the total momentum of a system or an object remains constant. There is no net unbalanced force acts on the system. When no external unbalanced force acts on the system, the total momentum remains constant. So we are going to prove this, okay? The recoiling velocity of gun is an example for conservation of momentum as well, okay? We are going to see another example, that is rocket propulsion. Ever seen this? How many of you have seen Mission Mangal? When the Mangalyaan is being launched, this is the scenario, right? So you are going to study about rocket propulsion in detail in your higher classes. Today we are going to see the recoil velocity. Before that, we'll see the proof on conservation of momentum. Okay? So now children, as always, I'm going to switch off my camera so that you concentrate on the derivation. It's very, very important, okay? Mark a 3-star and concentrate on it. So, am I audible? I hope I'm clearly audible. So children, this is the diagram in front of you. There are two balls moving with velocity u1 and u2. One has mass m1 and the second has mass m2. They are labeled as ball A and ball B. Before collision, during collision and after collision, they have velocity v1 and v2 after collision, and rest is the same. So this is the diagram for the proving. Now we are heading towards the proving. Okay. So we are going to write initial momentum of body A. You are going to write A here in short, and you have to write body A. Keep doing it with me. It will be m1 u1. What is momentum? Mass into velocity. So this is what we simply did. Mass into velocity. m1 and the initial velocity is u1. Initial momentum of B. What is the initial momentum of body B? Mass is m2. Velocity is u2. Right? So initial momentum of A, m1 u1. Initial momentum of B, m2 u2. Similarly, we are going to write the final momentum. So final momentum of body A. Come on children, tell me, what is the final momentum? Mass remains the same, m1. Velocity changes to v1. Final momentum of body B. What is it? Mass m2, velocity is v2. Simple. So what we did in the first step, we wrote the initial momentum for the two bodies A and B. Second step, we wrote the final momentum for the two bodies A and B. Isn't it very simple, children? Now, we are going to write the total momentum of the system before collision. So, total momentum, I'm sorry, that's not F, that's T. Total momentum before collision, children. So, how many of you can tell? It's a very easy question. Before collision, what is the total momentum? Add the two initial momentum of body A and B. m1 u1 plus m2 u2. Very simple. Similarly, you are going to write the total momentum after collision. So, I am going to clear it now. In place of before, you simply write after collision. And u1 की जगह क्या हो जाएगा? v1. u2 की जगह it will be v2. See? v1 and v2. Simple. After collision. Right? m1 v1 plus m2 v2. Now, can you find out the rate of change of momentum for body A? I am going to clear it, children. Okay. So, rate of change in पिछली derivation में we did this. Remember? Rate of, that's too awful. Okay. Rate of change in momentum. Let's simply write it as P. Better option? Rate of change of momentum for of whatever you write. A. For body A, what is the rate of change of momentum? Final momentum minus initial momentum upon time taken. Can you write that? Final momentum minus initial momentum upon time taken. What is the final momentum? m1 v1. What is the initial momentum? m1 u1. Right? And what is the time taken? dt. Rate of change of momentum is written as dp by dt. Remember? We did this in previous lectures. So, rate of change of momentum for A. What is it? m1 v1 minus m2. sorry, m1 v1 minus m1 u1 upon dt. Right? Now let us proceed. Now what is the second law of motion? Force acting on body A is rate of change of momentum for the body A. Force acting on body A will be equal to rate of change of momentum for A. What is the rate of change of momentum? We have already found out V1 minus M2. Pardon, children. M2V2 by dt. Clear? Now is it clear? Yes, that's M2. M2V2 upon dt. Done? So force is equals to rate of change of momentum. That's for body A. Similarly, you can find out rate of change of momentum for body B. What will it be? What will it be, children? M2V2 minus M2U2. You are finding it for body B now. Divided by dt. Simple. Now what is the force on body B? Tell me. Is it the equal and opposite force? So can you write it as minus F? अगर बॉडी ए के फोर्स को F लिखा तो क्या बॉडी बी के फोर्स को माइनस F लिख सकते हैं? Why? Because it is acting in opposite direction. Right? We can write it as M2V2 minus M2U2 divided by dt. Okay. So now you can equate the two equations we got. What did we get? I'm doing it for you. Just a second. Equate the two equations. Come on. M1 V1 minus M2 V2. ये हम बॉडी ए का लिख रहे हैं. Right? Listen, children, I was saying that you have to equate equations 1 and 2. This is the equation. Rate of change of momentum of body A is equals to rate of change of momentum of body B. Now, tell me, children, can you simply cancel out dt and dt? Right? So, what is the law of conservation of momentum that you have proved? Should we see it in next page? Just a second. I am clearing it, children. dt and dt is cancelled. Clear? Now, children, this is the simple equation we have proved. Okay? Is that clear? This is the equation for conservation of momentum. M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. Right? So we are done with the proving. Now, children, I am back with the next topic, calculation of recoil velocity of the gun. This is also very, very important. But this we are going to continue in our next lecture. Right? Till then, how many of you understood each and every point in the lecture? The derivation, the examples. Come on, hit like, children. Hit like quickly, hit like now. Yes? Hit the like button, press the bell icon for recent updates. Don't forget to like, share and subscribe to our channel and show some love towards me and towards education. Right? Till then, bye-bye. See you and very, very happy Diwali. Bye children.